Hiya, let's talk about measuring. You're probably like, Mr. Bauman, I do not need you to show me how to measure. I've been measuring my whole life and I can totally do it. You're a liar. Let me show you why. Here we've got the metric ruler. I know, weird, right? It's not measuring in inches. I know it goes to 12 and it should be like a foot long or whatever. This is in metric, okay? Which means millimeters, centimeters, and it would go all the way to meters, but it's not long enough. It would need to go all the way to 100 centimeters for it to be a meter long. So it's a very short, ruler. Okay, here we go. So normally when you're measuring, right, it's in inches and that's fine and whatever, but we're talking about centimeters and millimeters. So why does it say down here? Because and you'll notice that the thickness of these lines on the M of the font, it's the same as the tiny little increments, the tiny little lines. These tiny little lines right here, these little guys, there's one, there's two, there's three, there's four. Those guys are millimeters, okay? And if you count very carefully, there's 10. 1, 2, 3, 4, 5 is the big one. 6, 7, 8, 9, 10 in every 1 centimeter. Because if you remember back to our last lesson, millimeters are 10 times smaller than centimeters, right? So each of these big increments 0, 1, 2, 3, 4, those are the centimeters that we're measuring in, right? And if it went all the way to 100, we'd have ourselves a meter stick because 100 centimeters is a meter. Okay. Cough. Let's figure out how to measure this red arrow. Okay, so first things first, you want to line it up exactly on 0. Now, are we going to get super duper all the way exactly? Like if we had a microscope and we looked at that, we'd be like, it's not exactly on 0, but it's good enough for now. So we're going to say it starts exactly at 0. Okay. Now, to measure the length of this arrow, we want to measure all the way to the tip of the point. Okay. So you're going to need to bear with me as we try and get to the tip of the point of this arrow here. Okay. So first thing, we're going to measure this in centimeters because those are the largest unit of measure that are available to us right now. And I'll show you how to convert it to meters later anyway, because I'm a nice guy. Okay. So we know, right? It's between 5 and 6 centimeters. So it's closer to 6, right? Some of you are probably just like, 6 centimeters is the answer. Round it to the nearest centimeter, right? No, don't do that. This is a science class, y'all. We're trying to be precise. We're trying to be accurate. This 6 centimeters isn't even, we're not even that close to 6 centimeters. What are you doing? You're almost a half a centimeter away. That's not that close. Close enough, right? Sure, because it's centimeters and they're small, but it's not though, right? Like, your pants are going to be too short, or your socks are not going to fit, or your shoes will be too tight. Like, shoot, none of that stuff's going to work. All right. So that's not good. 6 centimeters, not good enough. Now, we know that it's at least 5 centimeters, right? So let's grab 5 and we'll put it on. Hello. That's odd. Okay, sorry. Sometimes there's lag. Here we go. Flip. 5. We know 5, right? 5 centimeters is here. 5.5 centimeters is here. It's bigger than 5.5 centimeters, right? It's a little bit smaller than 6. So would you say that it's 5.6 centimeters? Check it out. Where's 5.6 centimeters? That would be if we put our pencil right here and we drew a line straight up from there, right? That'd be like that. Now, you'll notice our arrow point goes a little bit past 5.6 centimeters. So we can safely say it's at least 5.6. Now, do we just leave it at 5.6 centimeters and call it a day? Let's all go get pizza? Guys, no, we don't. We don't do that. We're not doing that. No, we're not in the business of being almost right. We want to be as close as possible to the correct answer, right? As close as we can possibly get. Now, our tool here is able to measure a little bit farther. Okay. So we know we can get 5.6. Now, we know this is between 5.6 and 5.7 somewhere. And if you look carefully, you'll see it's a little bit closer to 5.6, right? So could we write 5.65 and probably call it a day? Yeah, that's probably good enough. But if you're looking a little bit more closely, you can see it's a little short of 5.65, which would be right in between 5.6, which is this line, and 5.7, which is this line. Okay. So what we want to do is we want to then estimate that final digit. So I'm going to underline that one because it's going to be estimated. Okay. So I'm going to say 5.63 centimeters, where my last digit was estimated. Okay. So I estimated that digit because that's as fine as I can get. So any instrument that you're using to measure with in my class, that's how I want you to measure. Figure out what the finest detail is and measure to that and then estimate the next one. Okay. Now, if this looked like it was exactly on 5.6, you could have written, excuse me, could have written 5.6 0, where the 0 is estimated, right? And it's totally okay and totally fine. And I'm happy with it if you underline that estimated digit. And I'm sorry, you should write centimeters afterwards because we need to know what unit it is. It's not 5.6 pigs, okay? It's not 5.6 parakeets. It's not 5.6 of your mom's apple pies. It's 5.6 centimeters, okay? I don't know why that to be your mom's apple pies. I mean, they could be, I don't know whose apple pie. Maybe you make a really delicious apple pie. I personally do not. Mrs. Bauman's the better baker in the family. I cook a little bit more creatively, so I'm not very good at baking because following directions is hard. I'm sure you can relate. Okay, so 5.63 is our estimated length of this line, right? So 5.6 is for sure definitely good. We know that it's a little bit bigger than that, but it's not quite 5.65. So we're going to estimate a number, 5.63. Boom, done, right? Now, let's take this number and convert it into millimeters, shall we? So millimeters, there's 10 millimeters in every centimeter, right? So if we've got 5.63, let's do it down at the bottom here. Just going to change it to black. Oh, never mind. I'm just going to leave it green. 5.63 centimeters, right? We want to end up with millimeters. Oh, I'm so sorry. I don't need to put that there. We're better than this. Okay. Now, in order to do this, we're going to do that same dimensional analysis thing. So we know we want to put centimeters on the bottom because we want to end up canceling our centimeters out with these other centimeters, right? So what unit is bigger, centimeters or millimeters? Well, if you look back at our ladder, you'll know centimeters are bigger. So for every 1 centimeter, there are 10 millimeters. How did I know that? I have it memorized because I've done this a lot of times, but all you have to do is look at your ladder and you'll figure it out. So what we're going to be doing is 5.63 times 10, right? 5.63 centimeters times 10 millimeters divided by 1 centimeter. So the centimeters cancel out. So 5.63 times 10, which is the same thing as taking this decimal place and just moving it one place to the right. So we're going to end up with 56.3 millimeters. Holy circle, Batman. This is the exact same answer as 5.63 centimeters. So the same thing. You can do the exact same thing and convert it to meters if you want. 5.63 centimeters is going to end up being how many meters? Equals some number of meters, right? Okay, so here's what we're going to do. We want to put centimeters on the bottom, meters on the top, because we want to end up with meters and we want to cancel out our centimeters, right? In order for this to work, we need to know how many centimeters there are in a meter. Well, that's easy, right? There's 100 centimeters in 1 meter because that would be the length of a meter stick is 100 centimeters. It's also 1 meter. That's why it's called a meter stick. So 5.63 divided by 100, right? In this case, is going to end up telling us how many meters we have. So getting a different color still, we're going to then take dividing by 100 is the same as moving the decimal. 1, 2, places to the left. So that we're going to end up with 0.0563 meters. Those are all the exact same thing. They're equal to each other. They're the exact same length. That's the length of this line in 3 different units of measure. Okay, that's it. That's all.